Hi, my name's Mike and welcome to tutorial number 9 on developing a game for the iPhone. And today we are going to be covering a sound engine. So we've done a lot in our sets of tutorials up until now, and today we really want to cover off being able to generate sound, because games without sound are pretty boring. So lasers, explosions, backing tracks, you know, all those sorts of things, user interface clicks. We're going to need to be able to generate sound somehow. So this is going to run through the creation of a sound manager, which is going to be a singleton class, a single instance class, which will allow us to load a backing track and play a backing track, and also allow us to load sound effects and be able to play those sound effects as and when we need to. So that's the idea. We're going to be using OpenAL for this, as well as the AV audio player to do the backing track. I had a look around. There's a whole bunch of different ways of doing audio, and to be honest, the most effective way I think for games is going to be OpenAL. The format and syntax of the commands is very similar to the OpenGL syntax. And having never ever played with OpenAL before, just spending literally a couple of days looking around this stuff, working through some tutorials that are out there on the internet, I've been able to come up with this sound engine, this sound manager. So I'm sure there are things that can be done to extend upon it, and we'll probably cover some of those as we go through. But this will at least allow us to get some sound going in our game, so that we can start to flesh out some of the details. So we're going to carry on from where we left off last time, which is our tutorial 8, and tutorial 9 literally carries on from there. So I'll just load that project up. Okay, there we go. And what we'll do to start off with is add some frameworks. There are some extra frameworks that we need to use here. And the way that I'm doing that now is if you right click on your target and you get the info for the target. Okay, here we go. You'll see at the bottom we've got the linked libraries. So by just pressing the plus button, it brings up for the particular SDK that you're working in. So for example, I'm working in the 2.2 SDK. It brings up all of the frameworks without you having to hunt for it. So back in tutorial 1, and in I think one of the other tutorials, I went off hunting around the file system to go and get a framework. It was actually highlighted in the comments. There was a much easier way of doing that by Joe. And the way of doing it was to just literally go into here, hit the plus button, and pick the framework you want. And then you make sure you're linking to the right framework for the SDK you're working in. Okay, so what we need to do is we need to go through here and add some of the extra frameworks that we're going to be using. So AV Foundation we're going to be using. We're going to be using Core Audio, the Audio Toolbox we're going to be picking up as well, and also OpenAL we need in here as well. Okay, so they're the ones we need to add, so I'll add those. Okay, and they'll go down here, and we can come out of that now. Now it goes and drops them just inside your top level folder, if you like. So what I normally do is highlight them and then just go and move them into the frameworks folder, just so that all the frameworks are held together. Okay, so that's added the frameworks. So now we can actually start to build out the code which is required to give us our sound engine. So I'm going to shrink down some of these things here. Okay, and common I'll do as well. And we've got our engine here. What I'll do is I'll create another group which I'm going to call Sound Manager. There we go, that'll do. And inside Sound Manager we'll go and create a new Objective-C class. Okay, and what we'll do is we'll call this Singleton Sound Manager. So this is going to be just like we did in tutorial 7. This is going to be a singleton class, so you'll only ever create, or you'll only ever be able to create one instance of this class, because it's going to cache our sound effects for us. It's going to make it nice and easy for us to, from anywhere in our game, call a sound effect and have that play. And we don't actually then have to keep track of any of the state of the sounds, because that's being done for us by both OpenAL, which we can query, and also it'll be done by our Sound Manager class. So we'll finish there, and what we'll do is we'll start off by, obviously as usual, putting in the header information that is going to be necessary for our Sound Manager class. So I'll just drop in the header information here. And you'll see I put a little bit of a header up here, and that's because there was a great article on OpenAL found over at benbritton.com, and that's really where I've picked up the majority of my knowledge now around OpenAL. That's where I went and ran through that tutorial to understand what are the key things that need to be done to actually get OpenAL working on the iPhone. I then did look at some others and got some other ideas from other websites, but the key one for me was the Ben Britton tutorial, which is a great tutorial and really gave me the base knowledge that I needed to pull together this particular class. So what we're doing is, first of all, we're importing a number of items here. So we're importing our OpenAL, we're importing our audio toolbox, and we're also importing our AV audio player, which we're going to be using. Now, the toolbox, we're going to be using some functions to load audio data and look at audio data file properties. OpenAL, we're going to be using to actually play sounds. Now, the moment the Sound Manager is not 3D, so in other words, I haven't implemented the functions that will allow you to play the sound in a different location to where you're listening to the sound, which is how you can get sound to appear on the left or the right or in front or behind, because it does support this 3D concept of sound around the listener. So I haven't implemented that yet, but I reckon that should be pretty straightforward to do. Because I'm doing a 2D game, I probably will later, to be honest, add some kind of 3D sound. So depending on where an explosion happens to where the player ship is, that's where you hear it in your headphones. I think that'll be quite cool. But just to keep things simple and to get it up onto the website for people to see, I haven't played with any of the 3D sides of the OpenAL yet. And the AV audio player, that's for playing my backing track, so any music that you've got to play. You could play the music quite happily through OpenAL. To be honest though, given the memory constraints of the iPhone and given the fact that, for example, the music track that I'm playing is a meg in size, it could be even bigger, then what I've decided to do is use the AV audio player because that will actually stream it for you. Again, you can have OpenAL do the streaming and you can develop it to stream inside your manager. I didn't really want to go down that route and that complexity for this tutorial, and also it's not something I've got my head around yet. So what I decided to do was really just stick with the basics of getting OpenAL working, using the audio player to play a backing track, which seems to work absolutely fine, and the audio toolbox to get some facts and figures about audio files. Okay, I'm also importing common.h here. This isn't needed for this tutorial, but what I'm doing is I'm using the vector2f. So when because I've been starting to have a look at the 3D side of things, vector2f is obviously something I want to use to store the location of different items. So I imported common here, but that you could actually get rid of that because we're not using that in our presentation. Sorry, in our demo today. We then I defined this max sources, and again, having a look around, what I've found is that the iPhone can play in OpenAL 32 different sound sources simultaneously, which is a pretty good number. I don't think that should ever be something that holds us back. And it just means that what we can do is we can have laser sounds and explosion sounds that are maybe being played very close together, being played in different sources or different channels, if you like. And that means then that you don't have an explosion that's halfway through being suddenly cut short as the next explosion plays. And it just gives you that sort of much better immersion and much better feeling to the sound that's coming out. We then set up our properties. We have something called an AL context. And I've seen this described as, if you imagine the air which the sound is actually traveling through, that's what the context is. It's setting up information about, well, the context really of the air. So what is the sound traveling through? And that's how I've seen it described in a number of different tutorials. We then have the device, which is the actual hardware we're going to be using. So we will be grabbing the default hardware, if you like, that the iPhone uses to do the playing of the track. So that's what the device is. And in this implementation, I've got three different arrays or dictionaries which we're using. So sound sources, in OpenAL, a sound source you could almost imagine as being like a speaker. In other words, that's where the source of the sound is actually going to come from. Okay, and that's where we say we can have 32 maximum sound sources. So what happens is that you have a sound source, which is like your speaker or somewhere where sound is going to be emitted from. You have your context, which the sound is going to travel through. You also have your listener, which is where the player is, or the person who's going to hear the sound is located. So that's called the listener. And you also have a buffer. And a buffer is where you actually load the sound data that you want to have played. So you create an OpenAL buffer, you load sound data into that buffer, and then you attach that buffer to a sound source, and then you play that source. And so because you've attached a sound buffer to the sound source, when you play the source, it actually plays the sound that's been associated with it. Okay, and that's really the key elements of OpenAL. Again, there's some great documentation on the internet, so have a Google and you'll come up with some good information about that. So what I'm doing is, because I want to make use of all 32 sound sources that are available to me, I'm creating a mutable array which is going to hold the ID for every sound source that I generate. So you'll see in a moment that we will actually go through and generate some sound sources, just like you can generate buffers in OpenGL. You can actually, or generate textures in OpenGL. You can actually generate sound sources in OpenGL. And just like a texture gets given a texture name or an ID, a sound source gets given an ID as well. So I'm storing those sound sources in an array so that I can move through that array, query each of the sound sources, get information, and so on. I've then got a sound library, and this is a dictionary where I'm storing a key, which is going to be the name of the sound, and where I'm storing a buffer ID. Okay, so again, when we load a sound into the sound manager, we're going to provide a key, okay, which is what that sound is called, so we can access it nice and easily. And we're also going to be generating a buffer, which is where the data for the file we're loading for that sound will be held. So I'm then linking that key and that buffer ID together inside the sound library. I'm then doing something very similar for the music library. So what I'm doing here is I'm creating a dictionary of keys, except instead of them pointing to an OpenAL buffer ID, I'm using the AV audio player. So the idea behind the music library is that you can load a number of different paths to different music files. So you could have 3 or 4 MP3 files, which makes up your music, and you could load each of them, and all it's doing is actually just loading the path. So you could provide a file name, and the full path that's needed by the AV audio player is being stored inside the dictionary. So when you say play title music, and title music being the key you're looking for, it will know the path necessary for that file, and it'll then get the AV audio player to start playing that file for you. So because we're using the AV audio player, we've obviously got the definition of it just here, which I'm calling my background music player. And I'm also defining a background music volume as well, so that you can define the volume of your background music. Because as we see in a moment, you can define the volume of your sound. Okay, so having a look now down in the methods that we've got here, we obviously have our class method, which we are defining, which is our shared sound manager, and that's what we'll be calling to actually get our instance of the sound manager, so we can actually start to play with the sound manager details. And then we have a number of standard methods here. So we've obviously got an initialize method, so we can initialize things. We've also got a play sound with key, and what that'll do is it'll take in the sound key, which is a text string you've got. It will take in a gain, or the volume if you like, for that particular sound you want to play. It'll take the pitch, so again we can fiddle with the pitch of the sound real time. Now I've got location in here, okay, because I want to be able to eventually pass in the location where the sound is playing from, but we're not using that, but I've still got it in the method because that's where we're heading. And then should loop, so in other words, should this particular sound loop at all? And if you had yes, then the sound will just continually loop until you ask it to stop, otherwise it'll just play once. We then have load key with sound, which does pretty much the same as the play, except we're saying the sound key I want to create is the sound key, you pass in a file name and an extension, which is what is going to be used to grab the audio file and grab the data. And I'm also passing in the frequency. Now, I'm being a bit cheaty here. There are some more complex ways of being able to open a sound file and actually look at the type of sound file. So query things like the channels, query things like the format, the bit rate, where the data is held, and so on. And by doing all of that, you can then go and dynamically pass in any kind of file, really, and work out what kind of file it is so that you can set the OpenAL properties properly. Again, I wanted to keep this secret, and I really wanted to understand what's going on under the hood rather than use somebody else's class and not really understand what's happening. So at the moment, this is hard-coded to take in a stereo 16-bit PCM file, and we'll see where that's hard-coded. But the one thing you can change is the frequency. So some files may be 44,100 Hertz, some may be 22,050 Hertz, and so on. So you can change that frequency value when you load the sound to get the sound playback that you're after. Okay, so one of the ways we could advance and enhance this would be to have the method that's loading the data become far more capable of actually identifying the file type, where the information is, and then doing all of that work for us, rather than us having to specify where things are done inside here. We've got a play sound with key, so we have a play music with key as well, and that takes how many times do you want us to repeat? If we had -1, it would repeat forever. If you had 2, then it would repeat actually 3 times. Okay, so it would play once, and we've asked it to then repeat twice more, so you would then get 2 more plays, so giving you a total of 3. The load background music is as you would expect. This gives us the ability to, using a key, create a music entry with a file name. And then you can set the background music volume as well. So again, you may want from your settings screen in your game to be able to move the volume up and down as necessary. And lastly, we can shut down the sound manager, which releases all the resources, etc. So that's our .h file. So what we'll do now is we'll move on to the implementation of that and actually look at the source code we've got for implementing that information. I'll just paste that in here. So we've got a bunch of private classes at the top end. So we've got one where we initialize the OpenAL settings, one that gets us the next available source, and we'll see what that does in a minute. Another one which actually opens an audio file with a given path, and another one which goes and gets the audio file size for us, given a particular file descriptor. Okay, so they're things we're going to be using internally. And at the top of this class, you'll probably recognize a lot of this code from the singleton tutorial that we did. So we're basically setting up a static instance or a static variable for our singleton sound manager, and then inside our method which is used to get the shared manager, inside a synchronize, which remember handles the multi-threading if that ever happened, we're able to say, well, if the sound manager is nil, it means it hasn't been initialized, then we need to allocate and initialize it. Okay, and when we've done that, we then pass back that instance. Okay. If you called alloc and init directly, then that will actually make the alloc with zone method fire. Again, within a synchronize, we say, well, if you're not using the proper class method up here, if you're doing alloc and init, then what we'll do is we will check to see if there is an instance of the sound manager already, and if not, we will actually go and allocate it for you and return that. Okay, so we'll return you an instance. If it doesn't already exist, then we're not going to do anything for you because one's already been created, and we'll just return nil. Okay, so we'll carry on going down. So inside here we have the init. So when an init is actually called and you do initialize this for the first time round, then what you have here is the normal sort of initialize pattern that you would see. We set up our sound arrays and dictionaries as you got. We also set up a base default volume for our music. And if we haven't already set up or initialized the OpenAL side of things, then we initialize OpenAL, okay, and then we return self, okay. So that's a standard initialization pattern. So moving on into the sort of the guts of the OpenAL now. So this is really where we start to define the OpenAL stuff. So in here, what we do is we get and assign the device using the ALC open device OpenAL command. By providing null, we're basically saying just give me the default device, all right? And that device is then loaded into the device variable here. If we get given a device, so if this is true, if the device is actually populated, we then define a number of other things. So we define the context by using the create context command here. All right, and again, we're just passing in the device that we want to use. As I said, this is the air really that the sound is traveling through. And then that context that we get created, we actually make that the current context. So you can imagine that you could, in a game, have different types of context. You may have, I don't know, one context which is going to be normal and above ground. You may have another context which is underwater, where you're going to add water effects to your sound, something like that, I suppose. Then what we want to do is we want to generate a bunch of sound sources, okay, which are like texture IDs, but for sounds. And what I'm going to do here is I've got a loop, and inside this loop I'm going to the maximum number of sources that are allowed, which is 32. And each time we go through the loop, I use this AL gen sources. Now, what I'm doing here is I'm saying that I want to generate one source, and I want the ID of that source to be dropped into the source ID variable. Now, there's nothing to stop you actually here putting 32 sources, okay, and it actually then populating here the name of an array. So you malloc something and you populate the array with all those 32 sources. What you could then do is then move through those 32 sources as I'm about to, but to be honest, for my purposes, I wanted to have the ability to use keys and make it a little bit nicer for the user to be able to go and play sound. So I'm generating one source at a time when you initialize the sound manager, and once I've got a source ID, I then add that to my sound sources array, NS array or NS mutable array. Now what you'll see here is that as I add the object to that, I'm actually wrapping the source ID inside an NS number object. Because inside an array, whether it's an NS array or a dictionary, you can only insert objects into there, so you can't you can't have primitives inside an NS array like an integer or a float. So you'd have to wrap that inside an NS number object, for example, which is what I'm doing here. So I'm saying create an NS number object, and I want it to hold an unsigned integer, and the unsigned integer is source ID, which is the ID of the source that we've just generated. So what we'll end up with is 32 source IDs loaded into this sound sources array. When that's done, we'll then return yes to say everything was okay. If something went wrong, we would just return no. The next method is around shutting things down. So what we do here is that if we ask to shut down the sound manager, we actually then go and again synchronize it in case there's a couple of threads that are asking us to do this at the same time. And if the sound manager hasn't already been shut down, then we go and run the dialog, which then goes and removes all of the buffers, it removes all of the sources and so on, and gets that out of the way. So then we move on to the load sound with key element here. And what this is doing is it's taking in a key, which is what we want to be able to reference the sound by in the future. It's taking a file name and extension, and it's taking the frequency. So the first thing we do is we create a file path by using the NSMain bundle and the path for resource. And so we pass in the file name and the extension, and it comes back with a nice path for us to that particular file inside our bundle. What we then need to do is we need to then grab a file ID, which is an audio file ID. So what we do to do that is we call the open audio file method, which we'll have a look at in a moment. And what that does is that will pass back, based on the file path, a file ID for us to use. So that's how we can then reference the file for the rest of this particular method. So what we want is we then need to find out the size of the audio file, which comes back as an unsigned 32-bit integer. So we're putting it in something called file size, and again you'll see in a minute there's a little helper method called audio file size, which uses the audio toolbox to go and get the file size property for this particular file and then bring it back for us so we can grab the file. And that needs an audio file ID, hence doing the audio file ID work just above. We then want to create somewhere for the data, so we need to be able to read the data in somewhere and then load that data into our generated OpenAL buffer. So what I've got is I've just got an unsigned char variable here called outData, and I'm mallocing that to the file size. Okay, so I'm allocating a chunk of memory, and the amount of memory I allocate is the amount of size that's identified in this particular sound file. So this is all pretty straightforward, pretty simple stuff to get your head around. Then what we do is we load the byte data from our file into the data buffer that we've just defined. Okay, so we're using this audio file read bytes method, which again is part of the audio toolbox, and we're passing in our file ID, we're passing in the size of our file, and we're also telling it where we want that data to be loaded. And then once we've done that, and we've actually done that loading of data, we then close the file that we opened earlier. Okay, so that file is now closed, we don't need to use it anymore. We then check to see if anything happens, if there's any problems. So if we got back a result anything other than 0, it means that there was an error that was encountered. So if that's the case, then we just literally drop an error out here, as you can see. And in fact, what we need to do is we need to not go any further if we have an error. So I'm actually going to put this in squiggly brackets because I want to be able to return like that if there was an error rather than carrying on. So if there isn't an error, then what we do is we create an unsigned integer which is going to hold our buffer ID, and then we run this openal command called algenbuffers, which, as you would expect, this is what generates our buffer where we're going to load our data. And the buffer ID for this particular buffer, we're going to load into this variable that we created here. And again, you could have a number here greater than 1 and it would generate that many buffers, so you could sort of do a mass buffer generation if you like. We're just doing only 1 every single time we load a sound effect that we want to play. We then use the openal buffer data command to say, well, we've got our buffer, we've got the data that we've read in, we know the size of the data, we now need to load that sound data, if you like, into the buffer itself. So we use the buffer ID, we use the format, and this is where I said we're hard coding the format. Okay, so it's a stereo 16-bit format that we've got here. If I actually get rid of some of that and hit escape and do format, oops, do okay, oops, well done. Do that. Okay, it's not giving me the autocomplete. Okay, I was going to show you the other options that are available there. But for the moment, I'm using stereo 16. There's also mono as well, ones that you can use, and so on. So that allows us to do that. In fact, let me just build this to make sure there's no errors coming up. Okay, so I've got an error here. Let me have a look, see what's going on. So if I do AL okay, let's have a look here. AL underscore, here we go. There we are, that's better. Not sure why I didn't like that. So you've got a mono 16, mono 8, stereo 16, stereo 8 are the different format options. So I'm hard coding this to be stereo 16 like that, which if I build, okay, that's better. So that's now giving me my my format, my hard coded format, which, as I said, if you wanted to be clever, you could probably have a method that went and dug out all that kind of data for us. We're then passing in the out data buffer, which is where the data is currently being held. We want to load into the AL buffer. We tell it the size, which is the file size, and then we give it the frequency. And again, this is the frequency being passed into this method, but we could have a method that actually goes and calculates that for us and gets that sorted out. Okay. We then load that information into the sound buffer, into the sound library. So what we have here is we say in our sound library, which is our dictionary, we create a new object, and that object is going to have a number inside it. So again, we wrap the buffer ID inside an NS number, and the key, the sound key that we passed in, is the key for that NS dictionary. So we could call this laser, and therefore every time we want to play a sound, we could pass in the key laser, and the sound manager knows that whatever sound buffer is associated with the laser key, that's the one that we want to play. Because I've done that, I then free the data that I allocated to store the data in the file, and we're done loading. So that's it, we've pretty much loaded the file now, and we've got a sound buffer containing sound data that will play when we ask it to. What we would need to do is attach that buffer to a source, which we'll be doing in a moment. The next method is around loading background music. This is a very simple method, and what we're doing here is we are creating this path again from the file name and the extension which we're passing in, and we're then inside our dictionary we're saying for the music key, which again could say title music, game level music 1 and so on. For the key, that's the path that you need to play. Okay, so it's pretty straightforward. I want to enhance this later on, so things like creating a playlist, maybe loading up lots of different things inside that particular library, and then being able to go next, previous, and sort of skipping through the files we have in there in some kind of playlist manner. A little bit like the track manager, which was in the sound engine that Apple was for some time using as their example of generating sound on the iPhone. We then move into the couple of little helper methods that we've talked about. One is the open audio file given the path. So we inside here we create an audio file ID and we use the NSURL to create a URL based on the file path. Once we've done that, we can then use this audio toolbox method to go and actually get a particular file, okay, or a particular file ID. So we pass in the URL, and what we do is we convert it to a CF URL, which is important that we do that. We pass in some read permissions, and we then also pass in where we want the audio file ID to be stored. Okay. Once we've done that, we then just check to see whether or not we've got an error. Okay. And again, I'm going to just, I don't know why I missed to do this, but we'll do that there. So if there is an error, we get an error and we return nothing. In fact, I'll say nil there. If there isn't an error, then we return that file ID which has been passed in. Okay, just do a quick build on that. So we then have the audio file size method here, which again, we pass in a file descriptor, which is an audio file ID that we've got because that's what the previous method actually gave us. And we then have two variables here. One of them is the out data size, so what's the size of the data, which is a 64-bit unsigned integer, because it could be a big number. And we then have the property size, okay, which is storing how big is the data size that we're bringing in, how big is each unit of data size we're bringing in, okay. So we're saying inside this unsigned 32-bit integer that the property size is going to be a 64-bit integer by using the size of command here. So the prop size will store the size in bytes, okay, that is needed to store an unsigned integer of 64 bits. Okay, so that's the byte size of that type. Okay, and up here we're actually saying we're going to store that type inside that variable. So we then use another audio toolbox function, which is the audio file get property. We pass in the file descriptor, which is this audio file ID. We give it a parameter, a value here, which is the fact that we want to get a file property, and it's the audio data byte count. Okay, so it's the data byte count, not all the header information that's in the audio file, just the data in the audio file that actually holds the sound information. So that's what we're after, and there's a big list of things you can read around channel maps and all sorts of other bits and pieces, and the documentation for this here actually does specify what all those things are. We then have the prop size, which remember is telling us how many bytes is needed for each entry inside the out data size holder, if you like, or variable, which we've defined further up. And again, if there's a problem here, we fill out that there was an issue, and in this one we are going to just leave it producing that because it will just send back 0 if there is an error. Okay, so that gets us our audio file size. So we've done a few things now. We've set up OpenAL, we've defined our 32 sources by default. We can now load both a music track and a sound track, or a sound file, and what we now need to be able to do is play them. So what I'll do here is we'll look at the play sound with key method, and we're passing in a few pieces of information. We're giving it a gain, which is the volume for this sound effect, the pitch of this sound effect, the location, which we're not going to use at the moment, and whether it should loop or not. So the first thing we do is we do this get error, and AL get error is one place where an error is stored. So if you get an error, it is placed into, or OpenAL records it. If another error happens, then it overwrites the previous error. So when you query the getError function in OpenAL, you get the last error that occurred. Okay, and you don't get, if you've not done anything in between hand, you've not cleaned it out, then it could be a bit confusing to work out, well, what kind of error am I getting, where is it coming from? So what we do is we just clear the error out. So before we start doing anything, we make sure that we've got the last error, we've put it into here, so that if any other errors occur, okay, then we know it's something to do with this piece of code that we're about to run through. So the first thing we do is we go into our sound library and we look for the key that's been passed in. And remember, that's going to be an NS number object. So we put the resultant ID, which is going to be, because it's the sound library, it's going to be a buffer ID. We put the buffer ID in this numval. Okay, now if numval is nil, it means that we didn't find the sound, so we're just going to return 0. Okay, we're not going to do anything else. If we did find a number, then we're going to get the buffer ID, which is an unsigned integer, by using the unsigned int value method of the NS number. Okay, the NS number class. So that turns our NS number into an unsigned integer, and that's now our buffer ID. The next thing we need to do is we need to go and find a source which we can associate or attach our buffer to, bind our buffer to, so that we can then play that source and that sound will play. Now remember, we've created 32 of them, and we want to basically go and play this sound with the next available sound source, because there could be sound sources already playing things at the moment and we don't really want to interrupt them. We want it to be played along with them so that we get our nice sound effects merging and mixing together. So there's a routine which we'll cover in a second called next available source, which will pass back the next available source ID for us, and we'll look at what that does in a moment. So once we've got that source ID, we do a couple of things. First of all, we just make sure that the source isn't associated with any buffers at the moment, and we do that by calling the source I and passing in 0. And you'll see that with a lot of the OpenAL calls, it's like OpenGL. We've got a source I, which means it's going to be taking an integer value. You've got a source F, which means it's going to be taking a float value. And if you have an FV, it means it's going to be taking a float value, but it's going to be inside an array. So you're going to be passing an array in. So we do this. We say for that source, okay, and for the source's buffer, so again, there's different options you can have here that you're going to be setting. We want to set it to 0 or bind it to 0. And then we do the same command again, except we bind the source buffer with the buffer ID. Okay, so that command there links the buffer ID that we've gone and retrieved with the source ID that we've retrieved. So those two things are now linked together, which means when you say for that source, go and play, it will play that sound. Okay, so you don't have a source always playing the same sound. One sound source can be asked to be playing different sounds by attaching different buffers to it. It's very much like binding a texture. Okay, you can have lots and lots of different textures, but you bind a texture that you want to render in OpenGL. You bind a buffer to a source in OpenAL. We then do another couple of things. So for that source, we then change the pitch. So there's a different, instead of AL buffer, we're passing in AL pitch, and we pass in the pitch. And pitch and gain are values between 0 and 1. So we do that. We then check our looping variable to see if we should loop this sound effect. And we use the AL looping, and we pass in either an AL true or an AL false, depending on that. And once we've done that, to make sure everything has worked, we then do a check. So again, we say go and get the error, so AL get error. If it's non-zero, something went wrong. Something happened up here when we were trying to associate buffers and sound and sources. So print that error message on the screen and return nothing. Don't do anything. To be honest, I'm sure there's probably much more error checking that we could be doing in here to make sure it doesn't ever go horribly wrong inside a game. But for the moment, this is working okay for my needs. We then play the sound. So we have an AL source play, and you identify the source you want to play, and that's it. It goes and plays it. So that's the command that does the actual playing of the sound. And then what we do is we have the source ID here. Okay, so that actually goes and plays. Sorry, that just returns the source ID that has just played that sound in case we need it. That might be useful for some reason. Okay. We then have here, and I'm just spotting that. You can tell that I've rushed this particular one out. I haven't even finished writing this particular method at the moment. But this is the stop sound with key. that we're passing in the sound key. So what I'm going to be putting into this method is the ability to stop a sound. And the only, not tricky really, but the only thing that we'd need to do in here is that we would first of all need to understand for a particular sound what source it's playing, because we need to stop the source, not the sound itself. So I think that's probably why I started to write it and haven't finished it, because it's a little bit more involved, because I'm probably going to have to change some of the other rest of the class as well, some of the other elements of the class, because when I basically play a sound inside a buffer, a sound buffer inside a source, I need to record what source is playing what buffer, so that when you say stop a sound, it looks at the buffer. From the buffer, it can then look up the source that's playing it, and then from that, it can then go and do the stop. So I'll work on that, and I'll post on the blog when I've got that code finished. We then have the ability to go and play the music file here, and I'm just noticing I'm getting a warning here, which I've not had before. Not quite sure why I'm getting a warning there. Okay, I'll have to have a look at that in a moment. But this is very similar to what I was doing with the play sound. We pass in a key, and from that key we look in the music library and we get a path. If there is no path, then it's an error, so we go and kick out and don't do anything. If there is a path, then we basically go and allocate the background music player and initialize it with the contents of that file. Okay, so whatever the path is, we use the URL to do it. And if there's an error, we drop that into the error, error variable that we created slightly above. If for some reason the allocate didn't work, so we don't have a background music player, we then again report an error message and we return doing nothing. If we do get a background music player, then we actually set the number of times it should repeat, which is the times repeat which we passed in. We then set the volume to be whatever the background music volume is. Okay, so it will remember because the background music volume is global to the sound manager. We will remember that, so no matter what track you play, it won't reset the volume for that track each time. It will use the same volume you used last time. And then we just use the background music player play function, which then will start to play that particular piece of music for us. The stop playing is very simple. We just say whatever is currently allocated as the background music player, we stop. Okay, and it will do that. We then have setting the background music. So we have the ability here to say, well, we want to set the background volume, so by passing in a volume value, which is between 0 and 1, we set that, okay? And at the same time, once we've set it, if the background music player has actually been allocated, so one exists, then we want to go and set that volume now as well. If a music player hasn't been created yet, then we don't bother setting its volume, but it will have its volume set to whatever background music is when we allocate it, as we saw a little earlier. That brings us down to the next method, which is this convenience method to go and get the next available source. Okay, so what we do inside this loop is we have something called a source state, which is an integer, and we loop through our array of sound sources. Okay, and we use the NS number, because obviously each sound source number is wrapped in an NS number object. And we use the get source I. So you'll know that in OpenAL you have the ability to query OpenAL's state. You have the ability to query values that it has. In OpenGL, sorry, OpenAL has the same. So you pass in the source number, which we're reading in here, and again we're using the unsigned int value to grab that. We're asking for the AL source state. Okay, so what we can do here is you can ask for the relative, the state, and the type. Alright, what we're saying is we want the source state, so that'll tell us, is it playing, is it stopped, is it whatever. And whatever the value is for that, we will drop it into the source state we defined earlier. If that particular source state is AL playing, and again, if I do this and we have a look at the pop-ups, we'll have playing, paused, and I think you've got stopped in there as well. Yeah, okay. So that gives us what's going on. So if we say playing, then we want to return that number. So in other words, if it's not playing, we've found a source that's not doing anything. So we return that source ID to the caller and say, there you go, there's a source ID that's not doing anything at the moment, use that to play your sound. If we get through that loop and we haven't found any available sources, we don't want to do nothing. So what we do then is we have the looping sound here. So we then go and have a look for any sounds that are looping. Okay, so we use the AL looping in here. If we find a sound source that's looping, then what we do is we stop it and we pass that source back. So the first source we find, which is a looping sound source, we stop that and we say, there you go, use that sound source to play your sound in. Now you could change that. I mean, that's just specific to the class that I've been creating. You don't have to do that. You could say, look, there's no sources, that's it. You could say, well, actually, I'm just going to take the first source. Or you could have a set of sources that you're saying, well, these sources here are used for explosions and lasers. I don't really mind. I'd like to go for an empty one, but if there isn't an empty idle one, I'll just use one from that list. Because the first looping source may be something you want to continue to have looping, like an engine sound or something like that. But this is just to show you the kind of thing you can do in here. And this is also coming from what I've seen in tutorials on the web. If that doesn't work, then what we do is we go to the very first sound source and say grab that. Okay, so that's very sort of hard, fast way of saying don't care, can't find an empty source, can't find a looping source, just take the source 0 and that's what we'll use to play our sound. Okay, so that's quite implementation specific, but you could play with that. But it does give you an idea of what and how you can get information about what's going on inside an OpenAL source. We then have a few methods down here which are really around, so these things like retain, count, release, auto release, they're to do with the singleton method, okay, and a standard pattern there for doing that. And then last thing we do here is we deallocate. So because we've created these sound sources, what we do is we loop through all the sound sources and we delete them. We then loop through all of the OpenAL buffers and delete them. We then release the sound library, sources and music library, and finally we make the current context null and then destroy the context that we've been using, and we then close the device, and that shuts everything down. So that's it. That's our sound manager, if you like. So what we need to do now is actually have a look at using the manager and getting it to play some sounds. So what I'll do is inside my let's have a look inside, not resources. Where should we put it? So what I'll do is I'll actually just create another group here and we'll call it sounds. Okay, and in here we'll just import a couple of sounds. So I'll import some existing files. Okay, I've got some sounds in here, and I'll import a music MP3 file, and I'll import a photon sound just here. Okay, so we'll add that. We'll copy them into the project, like so. And what we now need to do is we need to go and initialize our music or our sound system. So inside our EAGL view, which we've got here, we need to go back to the header file and we need to import our singleton sound manager. Okay, what I'll then do is just here, we'll say sound manager, and we'll have that singleton sound manager, and then we'll say that's shared sound manager, like so. Okay, so we'll then drop into the source again, and I think what I'll do is just at the end here say init sound. So what we want to do is say that our shared sound manager is equal to our singleton sound manager shared sound manager, which is going to be the instance that we pass back. Okay, so that's given us our shared sound manager. Now we want to load a couple of sounds. So if I say shared sound manager load sound with key, and I'm going to say this is going to be called photon, like so, and the file name is photon. The extension is a CAF file, which is an Apple audio format file, and I'm going to say here that it's 22050, because I think that's what the frequency is, but we can play with that later. Okay, I'm also going to say shared sound manager load background music, and we'll say that was called, we'll call it music. The file there was called music, and it was an MP3, like so. Okay, so build that, see what that does. Okay, that looks alright. Got a warning now. As I say, I'm not quite sure what that warning's are. I'll have to look into that, but I think it should be okay anyway. And then we could start to play our music. So if I say shared sound manager, play music with key, and it's going to be music. There we go. And in terms of repeat, we'll say -1. So what that's going to do is it's going to just repeat that background music over and over and over again. Okay. For some reason that warning's gone now. That's very strange. So let's play that. Let's run that and see what we get. Okay, there we go. So you can see that we're carrying on from our particle system one, and we've got some background music playing, which is quite cool. So we'll stop that. Right, so let's add to that and make some changes here. So if we go back to our code, what we'll do is we've got this photon sound, okay, which we've loaded in here. So we'll go down to where we have our touches at the bottom, just here, okay, and I'm going to add in here to play another sound. So we'll say shared sound manager, play sound with key, and it was photon. We'll say the gain is full, we'll say the pitch is full, we'll just put in a blank convict for the moment, and we'll say it won't loop, like so. So build that and hit play. And this should give us our background music and the photon. And every time we shoot the photon, we get our particle emitter. So a bit funky. But actually showing you having those things working together. And if I do a quick round of these lasers, you'll see that they actually overlap and work quite nicely using those using the sound sources we've got. Cool. Excellent. Okay, so that's got some sound up and running. What we can do now is just have a look at the tool to actually create the sounds, or to create sort of CAF format sounds, because being able to convert from one format to another is quite a handy thing to be able to do. And there is a tool that comes with the Mac called AF Convert that lets you do that. So what we can do is, if I have a look here, okay, so clear. I'm inside my music folder, and what I'm going to do is, in fact, if I CD into tutorials and then into sound. Okay, so what I've got in here is I've got my MP3 music file, so I may want to convert that, or I may want to convert, let me think, let's go for an explosion or something like that. So we've got here a laser.wav, okay, so what I could do is I can say, let's have a look, I've got a command back up here which I've already done. Here we are, so AF convert, okay, and then it tells you the format you want to convert to and the format you're converting from, okay, which is this is a PCM 16-bit file, which is a WAV file. Again, there are some instructions for this if you have a look, and there's lots of different formats you can convert to and from, which is handy. So if I say laser, oops, can't type today, laser.wav, and I'm going to call it laser.caf, like that, and that's it, that's converted it. Okay, so if I have a look in that folder, let's go into tutorials, and into sound, okay, and inside here we've got our laser.caf. There we go, very simple little laser sound there. Okay, so that's our CAF sound that we've gone and created, and you could then load that into your project just like any other sound, really. So what we're going to do now is load our sound in. So inside sounds, we're going to do an import of an existing file, inside sounds, and we'll do laser.caf, which we just created. So that's copied in, that's in there. We then do another one here to load that in, shared sound manager, load sound with key. We'll call this one laser, and we'll call it, oops, no it's not, it's laser, and it's a CAF file again, 22050 is the frequency. Okay, so that's that, and if we go down to our touches, we can, I already had laser in there, we can have laser in there as well. So if we now run this one, we have our little laser sound going on, and there should be no reason why we can't have a bunch of these going at the same time. So we could say photon, no, like so, build that. So we should get both those sounds play when we hit the screen. Which they are, but obviously the way that, the one thing you do have to be careful of is because it mixes the sounds together and the frequencies can sort of cancel each other out and stuff like that. So what I could do is I could actually make this one a lot quieter than the photon and see what that does. They're very similar sounds in very similar frequencies. If you had explosions that were doing that, that would probably sound quite different. But there we go. So that's the basic sound manager up and running. I'm sure there are improvements that can be made to it, and if I do make them, or as I make them, I'll obviously post those up onto the blog as well. But I hope you enjoyed that. I hope that's going to be something useful for you to at least get you started on building your own sound manager, and being able to play music as well as being able to play sound effects in your game. So enjoy, and I will be joining you soon with tutorial number 10. So I'll have to think of something special for 10, seeing as it's going to be the 10th one we've done. So enjoy, and I will be back with you shortly. Thanks very much.